make it like I hate it automatically because it's my voice and everything else. So let me see though if this is.
There's a problem at the bottom of probability, an infinitely large problem, and it causes modern mathematics and physics no end of trouble. Books and reams of paper have been written on it, and it causes us to get all kinds of calculations wrong. It's a paradox with no clear solution, supposedly. The good news is there is a solution to the problem, a solution that not only solves a 150-year-old paradox, it may help us understand some of the baffling results from modern astronomy and even help us learn about the shape of the universe. The bad news is that almost everyone has been taught something that makes us blind to the solution, something 2,300 years old. It's well recognized that to properly evaluate a probability of a truly random selection, you have to know all the possibilities. If you're flipping a coin, there are 3, heads, tails, and the edge. If you're picking a unique playing card from a standard deck, there are 52. But what if there are an infinite number of probabilities and possibilities?
So I stopped it there, just in the interest of time. But is this, like, any suggestions at this point? What would we, anything to improve, anything that?
What mic we're using?
Yeah, I don't know how much of this is a function. So of the microphone, I've got like an aftermarket microphone that many of the influencers or whatever use. So like I literally was like, I see that one that they're using, I will get that one off Amazon. It's probably not a good microphone. And I did the recording literally in my closet because that had the most sound absorbing material that I could find. So that's my best shot in getting the nod from the actual industry pro here. Yeah, so maybe to you first. What do we do to make this better for the first cut of lower quality stuff that we're doing?
Yeah, your audio was decent, but that was the first thing I noticed. I was like, okay, that could be on the better side. But I get if like you're trying to spend this specific amount on like you don't want to spend more. If that works, it's fine.
These guys here have presumably phenomenal mics. Do I just look at
it? You can snag a mic from here if they let you borrow it.
Okay.
Do that.
Okay.
And then video-wise, is that the very beginning of the video?
Yeah.
That's the very first thing?
Yeah. I know we need like an intro screen and all that stuff too.
I mean, later down the road, you might want one. But if you did it in that way, where like the time lapse that you were on, that was good. Like, the time lapse piece I found was very entertaining.
Yeah, blatantly stolen from Minute Physics, not an original idea. Like I was very pleased because it looked very much like his earlier stuff. His later stuff looks better, but I don't know any better.
But yeah, I thought it looked good from a video side of things. But audio, yeah, if you want to steal a mic from somebody's here.
So probably a function of the microphone, you think? We're almost certainly.
Yeah, I mean, if you can get a lav, that'll be fine. But if you're just at a desk at this point, like, just get like I don't know what the mics here are, but if you can happen to grab a Shure mic.
Yeah. Yeah, they do. I'm pretty sure.
Yeah,
pretty sure I do have this. Yep. Okay.
So do you want a little reverb or compression in there?
So I also realized as I listened to different YouTubers that my favorite videos are the voice over portion of it is done by people with a higher pitched voice than I have. So I'm almost immediately deciding that I'm the wrong person to be doing audio.
Yeah. Well, yeah, I get it.
Right.
I get it.
The Minute Physics guy, the Veritasium guys, they're all tone is they're what I think you call it pleasant tenor voice.
Yeah.
It might sound different in a bigger room. Like it might be subconsciously muffling because you're in a small space.
So I initially did, that's true, and I realized like why am I whispering into the mic? I'm the only guy in here. It's because I'm the only guy in here. So I tried to talk in the same voice that I'm talking right now, and then realized, of course, that the words that I'd written were not written in a conversational manner. So I know I need to do a rewrite where it's a much more conversational.
Yeah.
If you went on the stage when it's empty,
Yeah.
in here, you would like how different would it sound?
I did my best at that. You got the best that I knew how to do on this one, so maybe more practice. But before I put too much effort into that, I was realizing maybe we just need to find somebody with a better voice to do it. So if anybody's got any recommendations of somebody with a pleasant tenor voice that would be good at this?
Chris.
He's like, directly into the bus. He shows up 5 seconds later, throws you under the bus.
You AI train 11 of the most popular YouTubers. And
Yes.
A synthesized voice of all 11 of them.
Like the way you're thinking, Mr. Type 1.
That could be turned into a nightmare too.
No, not that voice. The voice of Sauron or something.
Does anybody know why I can't get the file that I've got saved on the iCloud drive to display in QuickTime on this iPad if it was exported from iMovie? So again,
AirDrop?
yeah, I can. Well, like I have the file here. It's just incomplete.
Is it downloaded in the background?
It doesn't look like it. It's acting like it's all there. Just try. It won't help us for the audio because, like, literally, I think when you play it, you get the speaker that comes out of there. I forget.
For sure.
So this I've got
Like you were
as a now exported file on QuickTime.
There's a problem with
Is
the bottom
there
of
a-
probability, infinitely.
How do I get this up here without going through here? Unless I just.
Yeah, because during the debate on stage, you sounded
Are
okay.
you on that network?
Should be okay. Which is what that's on. Do I look like a boomer yet?
I thought your voice sounded good there. Does this guy share on the screen?
Oh, I can. I just haven't.
Can you connect the laptop to the projector?
I don't know why AirPlay's. I mean, I gotta try
It'll give you that, and then you just do it again, and it'll for some reason work.
Makes sense.
Right. It's on the same theory. Just reboot it. It'll be fine. Okay. See what happens.
Much trouble. And it causes modern mathematics and physics no end of trouble. Books and reams of paper have been written on it. They cause all kinds of calculations. It's a paradox with no clear solution, supposedly. The good news is that there is a solution to the problem. The solution is not only solved in 150-year paradigm. It may help us understand some of the battles of modern astronomy and geophysics.
It's okay.
What about the shape of the universe? The bad news is that almost everything is impossible.
You could also add some sound effects to different parts of the drawing.
You can add some sound effects. As you can see, I'm incapable of literally putting this on a projector. I'm maxing out my technical acumen at this. Yes, you're right. I will. I know, like
There's points where you're like, yeah, I don't want to really get too deep to it right now. Don't add sound effects because you will be up for hours.
Be chasing just the sound.
Just doing sound effects.
Yeah, I believe it. No, I can make this a little better. What about have to work in what's the famous yell where the cowboy gets shot in the leg, and now it's in literally every Hollywood movie. I can't remember what that one is. Have you guys seen that?
Wilhelm?
There was an old 1950s cowboy movie where one of the cowboys gets shot by a Native American Indian with in the leg, and he does I can't reproduce it. Anybody wants to give it a shot, but he does that famous "ow" yell, and Hollywood sound folks have loved it so much that it is. If it's not in every movie, it's basically in every action movie. It's in every movie you've heard. They throw it in at least one time. And if you heard the yell, you would very much recognize it. It's pretty good. Okay, well, at any rate, that's where I'm headed. Now I'm going to do a rewrite. Now that I've spoken it, I realize that doesn't sound right. But we'll start this one, and then what I think I've heard y'all say is the next one we'll do is problem of pain. And what I'm guessing I'll do is just hop back and forth between science, whatever videos, and theological or philosophical videos, just so that we start to build it. And I think I've also heard us say that this strategy would be don't release it now, build, and then release on a schedule and be ready to interact with local material as well. But bottom line is, thank you, Eric, and everybody for your patience on this. Hopefully we're getting there. And now that it is easier to do now that I've worked through the mechanics of it. It's not hard. The hard part is writing it. But this drawing stuff, like what you saw in the drawing there, that was less than 30 minutes of work. So super easy. And I think that the next part for this video is going to be hard because I have to trace something out. So it'll take twice or 3 times as long as normal. But I'm telling you that for a video that's going to be of this length, I don't think that's more than an hour and a half to 2 hours worth of drawing. So like you can knock that out super fast. And of course the speaking portion of it took 10 minutes. So it really is all in the writing. So that being the case, if anybody wants to join in and help on the writing, I'm realizing that's the heaviest lift here, and I'm also realizing that my writing on this was not good. So anybody who feels like that's something they would like to do, or is like, yeah, I can do that better, Scott. Just get out of the way of the keyboard. I'm with you on that. Okay, so that's just a little bit of update. We'll go back to normal solid ground style, which is. Let's go talk. We can talk more about this. We can get into any topics people have been trying to hold for a long time. The floor is back open to you again.
And a follow up on the infinity problem.
Okay.
When someone brings up, it's like, well, in infinite series, or like maybe time, there's like a before and after. So infinity might make sense, but what if there's a infinite multiverse where each universe isn't like related to each other in a series, and so it's just a brute fact that there's an infinite multiverse?
And when you say the universes are not these individual universes are not related to each other in a series, what do you mean?
That they're not like numbered 1, 2, 3.
As in, this one came first, and then that one came next, and then that one came next? Or are you saying they all exist at the same time?
They all existed, yeah.
So, as I understand it, the multiverse concept are bubble universes, you might call them something. This is one of them, where each one of these bubble universes is, they're expanding themselves. Maybe some of them are expanding, and I guess they're all expanding on average. But then these are also expanding away from each other in some way, or bottom line is these are not causally connected domains, so that these things aren't touching each other. Because once they become causally connected, they're not other universes, they're just our universe, another part of our universe. So that's one concept of the multiverse.
The movie version of it that people believe.
So
they're not like expanding away from each other, they're just like in different dimensions.
Yeah, so I think the problem with the movie versions where you can dimension hop from your own is those are causally connected domains. That's just one universe. It just means that the spatial portion of it, what's supposed to be happening there is you've got some weird shaped universe like this, maybe, and at least theoretically what we would think is if you're going to hop from one part of the universe to the other, you've heard the kind of the wormhole idea. You're basically creating a temporary connection between these two domains of the same universe. So if you had a multiverse where you can hop in between them, these are causally connected. Or potentially causally connected, or in the past causally connected, which means by basically kind of a light cone theory of thinking of it, there are, for any event that happens in here, this was just a cone to talk about what happens in this direction. This would go in all 360 degrees spherically. That this is now a causal domain around that event. So these events can still be ordered.
That's not how they model it.
This is a way that they model it. This is how wormholes work. But what I'm saying is if you can reach out to another universe, how did you get there?
I mean, they just say science fiction.
Yeah, but the point is if we're trying to think of it in a way that would actually be realizable, that is to say is real. So think about that one, but ultimately multiverse theory assumes if multiverse theory is talking about our universe, so it all started from expansion in one place, and now there are here I'm making hand signals when I got something to draw. Here was kind of the big bangish thing, and then it's gotten this big, and that the retreat of this region of space and the retreat of this region of space are so fast from each other that this resultant relative speed is greater than c, then these are no longer causally connected portions of space, or maybe not this. Yeah, they're no longer causally connected portions of space. That doesn't make these two different universes, though, does it? They're no longer causally connected. In fact, we've got that already. This is part of something called the horizon problem right now, which is physics don't have a good explanation for why, when you look in that direction, the oldest light you see, the cosmic microwave background radiation, is 2.7 Kelvin, and the oldest that you see over here is 2.7 Kelvin as well, and it's like 0.00001% different. So you've seen the map, maybe that map that kind of looks like this, and it's got blue and green and orange and yellow and red dots on it, and those are relative temperature differences of the cosmic microwave background radiation. They have tuned up the contrast so much on that one. That difference between the red and the blue is 0.00001% or something on that order. So it's virtually identical on both sides. The problem is they were never in causal connect. They were never in heat sharing connection where these two could have come to equilibrium, and that's considered the horizon problem. So we kind of see that already.
But that's one of the pieces of evidence for the Big Bang, right? It's just what you're saying.
Yeah.
That there must have been some single source of all this. It's not that it must be expanding in all directions at the same time.
It doesn't necessarily. So they're related, but they're not. It's not one because of the other. In an expanding universe that happened Big Bang style, what you would expect is different temperature differences. So it's very surprising that temperature difference is virtually zero compared to that one, because in an expanding universe, you would expect slightly different distribution of matter. In the expansion itself, there's no immediate reason why this temperature and this temperature should be that close. Normally, if you want a temperature to smooth out, it's in some sort of container, and over time it comes to equilibrium. So this part interacts with this, this bumps into that, and temperature is just the average of the kinetic motion of whatever the stuff is in it. So in air, your air temperature is all your air molecules bumping around. If you have really hot air around here, it's thin. In cold air, it's dense. These aren't moving around. These are moving around fast. But these bang into these, and they make them go faster. And these, being slower, slow these down when they get banged into it. And over time, they bang into each other enough that they've averaged out, and you come to equilibrium. In a expanding universe like this portion of it doesn't bang around with this portion. So why are they at equilibrium? That's the question. And the answer is it had to have been so smooth at the beginning. It had to have been at such equilibrium at the beginning. But this is not accounted for in the normal laws of physics of there's not a reason for that to have happened. So it's considered a super fine-tuning problem.
You would say, I think it is fine-tuning issue. But they would say because no space location in space, that makes sense, right? XYZ in space is further away from the original source than any other space location in space.
Yeah, they do say that, but that's only true if the universe is not spherical.
Not spherical.
Yeah, if the universe is spherical, that's not true. So if it began expanding from this point,
right, then
over here, and we slice this. This is just
right.
Yeah. Then this point is further from the center or is closer to the center than this point. So you do have an order of distance from a center of the universe. So the only way you don't get that is if the universe is either A, completely unbounded, in which case there's no such thing as a center for it, or it's a torus or something like that, where where the universe is, I'm not good drawing tori, but it's something like this, and so your space domain would indicate something like, you guys get the point, right? aside from my terrible game. So if you're here and you can go around the universe and come back to the same spot, or you can go around the universe this way and come back to the same spot. So you kind of still have an infinite surface of part of it, like you would on a sphere. But if you said, what's the center of this torus? There's no reachable space in the middle of this torus. So, but you still could say this point is closer to this point than it is to that point in some region, in some idea. But this one is closer to what you're talking about, where they're not related to a center, so to speak. But the problem with the torus kind of idea is this is a three-dimensional representation of a four-dimensional space. So this one over the sphere is the simplest answer, and the data that we have actually most simply interpreted, most straightforwardly interpreted, says that the universe is spherical and that we're close to the center of it. This is why Hubble said there are only two options, and one of them is too horrible to contemplate, and the other one is it looks the same from every point in the universe.
Right. So to be clear, it's a three-dimensional representation of the surface.
Yeah.
And my understanding, at least, of all cosmic theories is you're not talking about it. Well, that's not true. But my understanding is that we're talking about it's a three-dimensional.
Yeah, more strictly speaking, the fourth dimension here is not time. The fourth dimension here, this is a non-Riemannian, this is a non-Euclidean surface.
Okay.
And so if you're gonna, for those that are not familiar with the math terms here, the hard part is representing density. So imagine that we wanted to map the air in this room. But let's pretend for some reason that the air right here is more dense than the air everywhere else. So, and let's say though that space and air are the same thing. Okay, so we're not mapping the air in space, we're mapping the air itself. So how do you map something that is of different densities? And the only way we really know how to do that in two space, we do it three-dimensionally. But in three space, we don't have a way to do that. We talk about a fourth dimension of like, how am I going to show that this is more dense right here than that is over there? And you have to have a way of depicting that. So it's possible, you've heard me say in here maybe, I don't believe in anything but three space. And that's when I'm talking about space itself. If we're going to include density in the concept of space, which I think we should, then it's still three-dimensional in the way that we think of it, but there's a fourth dimension, which is the relative density of that space, which does need to be depicted. Now, you and I can kind of think of that, right? We can imagine almost walking through space that's thicker. So right now we move through space, but let's pretend that we only move through air. So here we are, and as we move, like not only are we moving through air, but we are air as well, so to speak. If we were moving through air, when we hit this denser region, we would slow down because it's more dense, and then we would speed up when we got through it. But if you're made of air, what happens? You get more compact, and then you expand again when you get to the outside. So that's kind of the difference you have to think about, which is not like our brains are not, it's not immediately obvious to us how to conceive of that. We certainly haven't been taught that way in schools, whether that's a function of our brain or whether that's a function of our geometry. But, remains to be seen. If you guys got a small child, they would like us to attempt to educate in four-dimensional reasoning from the beginning, and they want to use that as an experiment, let us know. I don't know if we can get that past the Human Subjects Committee, but there we go. They're going to need glasses, I'll tell you that.
So I think Seth's question is a good one, though, in that the popular understanding is a Marvel understanding.
Right, but the Marvel understanding is not possible.
It's maybe not, but what they're playing with is...
Four separate timelines.
Yeah, but what is a timeline? It's a causal chain.
Right, but there's multiple ones that they're all independent.
So they're only independent if they don't interact at all.
So that's what they're playing with. They're playing with independent, non-causal universes, we'll call them. And what happens if you do somehow get a link between them? What happens to the causality of those two universes? And so that's what they're kind of investigating in that, if you will.
All right, so here are two universes. Yeah, so I wrote
So
on.
I understand what you mean, But the question, I think, is still valid because it's a popular.
Yeah, but let me give you the answer. So I wrote the answer to this in a paper's response to Brian Leftow's talking about the Trinity and the nature of God. And we wanted to say something like this. Here's timeline S1, and here's timeline S2.
Sure.
And like you could say, like, they're not connected. So how do you know whether, I'm sorry, well, let me do that differently. I got a better way of doing that. We're going to say here's timeline T1, here's timeline T2, and here's some event S1, S1, and here's some event S2. How do you know whether S1 occurred before, simultaneous with, or different than S2 if these are independent, non-causally connected spaces?
Right.
Now, here's the answer to that question. If you create a connection between these two, so that you know that this event, Doctor Strange opening the portal, and this event, him dropping Loki through it, who says, I've been falling for 30 minutes. So these two are now connected. Now you know, at least anything that happens over here, S3, S2 happens prior to S3, but also S1 is prior to S3. And now the question is, you can try to work out where are S1 and S2 in that timeline. And then what you have to know there is what are the relative rates at which these timelines are moving. So if this distance right here is 100 years, and this distance right here is 200 years, then you could work that timeline out, because now you have a connection between the two timelines. So that concept of these are separate universes that are not, you don't know the order at which they're connected and they're non-causally ordered, that's not true anymore. Because part of what is at least reachable by S3 from S1, like this timeline is now connected here.
But the two big bangs weren't causally connected.
They're not causally connected, but they're orderable now. So you do know which one happened first. That's the point I'm making.
Or what if they were the same distance?
Or they're the same time, not the same time.
Okay.
But the bottom line is you can order. You now know. You now are not you're not making the statement. There's no way to compare these two, the order of these two sets of events. What you can say is, no, I can tell you, and if these are both deterministic universes, these are the things that were causally connected to here. But now, this right here is now causally connected to this right here. So those are not separate universes anymore by the definition of a universe, which is a causally connected domain.
But if each Big Bang happened lined up with each other, they're still not.
What do you mean by lined up?
I mean, most of them use the B theory of time, that you just have a bunch of slices, and so if the first slice for all the multiverses line up.
These don't have. This is independent of B theory of time. This works either way. With A theory or B theory, same thing.
Right, but you still can't say one universe was before another universe.
If they're causally connected, they're one universe. That's the definition of a universe. What's the definition of a universe? Like, if you're going to say these are separate universes, what do you mean by they're separate? They're not one's reality and the other one's not. They're all part of reality. So in that sense, if universe just means all that's in reality, then by definition anything that exists is in one universe. But if what you mean by that is, no, I want to talk about the set of all things in reality in such a way that means they're causally connected, and if there's a causal connection between them, they're now one universe.
And then so they just say, okay, the universe is infinite.
Say it again.
So let's say the universe is infinite.
Well, they can say that, but if this ends up in a dot and this ends up in a dot, these were two, originally, you could say, up until this point in time, these were independent, non-causally connected domains, and then they became causally connected. Or as you see in our universe, you have a causally connected domain, and then eventually, once they hit a certain distance or rate of expansion, they become non-causally connected. But the fact that U1 and U2 are now no longer causally connected doesn't mean that they weren't causally connected in the past, which means you can order these events as well, which means they're the same universe.
Right, but then that would mean an infinite universe.
This is a finite universe.
I know, but in the timeline one, if you just keep stacking timelines, and there's an infinite number of them.
If you keep, say that again, stacking timelines where?
Yeah, instead of T1 and T2,
Oh, down
well,
here.
they're not, they shouldn't even be numbered.
Okay.
If
You're
you
saying
know
that
which one's 1 and 2.
you're saying there are more of these.
Yeah, there's an infinite number. Or
Okay.
infinite.
An infinite number of universes.
Yeah,
Are they causally connected?
they could be. I mean, they're not. You could say infinite number of timelines.
Well, my point is this: whatever number are causally connected are not separate universes; they're all one universe. And the number of non-causally connected temporospatial timelines—that would be the number of universes in the multiverse. But once they become causally connected, they're the same universe.
Okay, but there's still infinite of them.
Okay.
But that allows an infinite universe where saying an infinite, you can't say there's an infinite number of past events, but if you go to the timeline thing and there's an infinite number of timelines,
Yeah.
now you're back to an actual infinite.
Yes. So the question is, do you think it's possible for an infinite number of universes to exist?
I mean, when someone says this, I'm not sure how to respond.
So maybe two ways. First, the thing that you got to at the end, which is there's some infinite number of universes that are non-causally connected. For clarity, that's not the Marvel version. The Marvel version is causally connected universes. And a causally connected multiverse is not, those are not independent universes, that's all one universe.
I mean, that part doesn't matter.
I know, but I'm saying there's two ways to look at it. That's way one, which is anybody who tells you that the multiverse is independent universes is wrong. Flat out wrong, demonstrably wrong. By any reasonable definition they're going to have of the universe. So
They say they can't interact at all.
if they can't interact at all, why do you think how do we have any idea that they exist?
Because it's an answer to fine tuning.
It isn't an answer to fine-tuning. Fine-tuning is only an answer if they're causally connected in some way. So you got some generator that's kicking out universes.
No, there's not a generator.
There's some universe-generating mechanism that's kicking out universes. They got to come from somewhere. So on the idea of quantum mechanics so this comes from somebody trying to rescue quantum mechanics in our universe. Because what became obvious was when you take quantum mechanics, which is very much a probabilistic way of looking at the world, and you say, here's our universe, which is an extraordinarily improbable universe by all the measures that we can figure out because of all the problems, some of which we talked about this morning. And you say, is it reasonable for us to expect that our random universe generator would have kicked out this universe? And the answer is absolutely not. It would have created a much smaller, much less complex universe. That's the easy. If you had a random universe generator, you would expect it to kick out very, very small universes, as an example. Those would be far more plentiful than our universe. And then you would expect them to kick out a bunch of universes that never got off the ground because they crushed themselves out of existence in the first microsecond. So at some point someone said, well, what if the reason that we've got the winning lottery ticket, that we picked a string of 30 double-digit numbers together, and we got the lottery ticket on our first win, maybe it's the case that we got a whole bunch of lottery tickets. Maybe that's what happened. And so we make up the idea that there's a bunch of lottery tickets out there, and that the quantum mechanical reality, existing reality that came from where? At a ground state that was gonna explode into a universal creation, which, by the way, cannot be done mathematically. There's no way to build a ground state that stays eternally at ground state and then erupts. There's no mathematical way to do that we can even think of. So throwing all that problem aside, being like, whatever, maybe we just don't understand the math. There's a universe generator out of, and it's the quantum world that's kicking this stuff out. That itself is the base reality that's generating these universes in a multiverse. So if you're going to turn around and say, well, no, there's one that we know of here, but for all we know, there are billions and trillions and gazillions of other types of universes out there that we can't even conceive of. Laws of physics don't even, okay, fine. Yeah, maybe there's also a bunch of unicorns out there too. Maybe there's a bunch of, maybe the Care Bears are real and the Smurfs and they're all living together in another place. It's just kids making stuff up. So it's just very non-scientific. If you're going to be scientific about it, the answer is we have to deal with stuff that we know. So the philosopher can break it into possible and impossible and say like, yeah, it's possible that those kind of things maybe exist out there. But it's not possible that they exist. This is where you go to a contingency and necessity argument, that kind of thing. And that becomes a philosophical argument. But if you're going to talk about it in physics terms, then you have to be able to resolve it in physics terms. Right? You can't make an argument from physics about time and space if you're not going to use potential laws of time and space for all this. So that's the point I'm making. So the problem with the Marvel universe is they're all causally connected domains in the Marvel universe. So they're all one universe. They're just different regions of space and time, space-time, and that they're connected and ordered. Ordering is very important in infinities, and I won't get into it now because if I get into it, we'll spend the rest of the class doing it. But hopefully that addresses your question.
It's also fair to say that given fine-tuning the universe, it's still a worthy question to ask, how could that be?
Yeah,
even if
absolutely.
Number,
We have to ask that question. How could that be? Yeah, and that's
but that's one of the things that people would throw out. Well, we just got lucky. We happen to be in the universe, which is ordered in such a way.
But that's why we run there were three possibilities. The universe is the way it is by time, necessity, or by chance, necessity, or design. It's not chance or necessity, therefore it's design. So you're exactly right.
I've heard that college is just different with multiverse. It's singleverse that expanded, contracted, expanded, contracted, expanded, contracted, and then you just happen to be on the lucky run that kept on going.
So if it's an expanding and contracting universe, so we'll do that by plotting. Here's time, and here's size of the universe. That looks like. Looks like this, or whatever, however you want it to be. That's the same universe.
Well, like this, it's the universe, and then it was no more, and then somehow we tried again, and it was no more.
No, even if you made this,
no more, tried again. Okay, now we finally got it right. We just didn't know all the other failures.
That's the plot. This is the plot with a discontinuity here. Remember the circle? When you were a kid and they drew the line and had a full circle, that means it was continuous, and an open circle meant it was discontinuous. So this point right here would be a point where nothing exists, and then nothing exists again or whatever else. But the bottom line is, even if nothing exists, so the universe completely winks out of existence, none of it's left, no matter, energy, any of that.
I'm trying to remember the argument because it was very similar to this, but it was not multi-universe. It was very much like, what if you got lucky? There was many universes in advance, and you just happened to be on the one.
So the fact that they say,
I'm trying to infer.
The fact that they say in advance means that they know it's ordered in a timeline. If it's ordered in a timeline, then it's causally connected. You cannot have a timeline that's ordered that is not causally connected. There's no way to order those two timelines. So if you say in advance, you're admitting that they're admitting that these are causally connected. Otherwise, they wouldn't know they're in advance. For all they know, that other universe you're talking about happened after this one.
Right. I've been looking for that argument.
You still run into the infinity problem that you're talking about, and you also run into an entropy problem.
An entropy problem that we can't even understand how much it's on God's side, so to speak. Yeah, because it's incredible.
What's the entropy?
Say again.
What's the entropy problem?
Entropy is a fancy name for simply how well ordered is something. So things that are stacked nicely are very, very low entropy. Stuff that's kicked all around the room, high entropy. Your kids' rooms, high entropy. Good library, low entropy. So in terms of those particular types of organizations. So the problem with our universe is that one of the worst problems that we have in the universe for, like, this just happened randomly, is the level of entropy that you would need for this universe to even expand to the size that we see today is something like 10 to the 120th power of like this particular measure of entropy that that we use when we talk about this. And that level, like they're 10 to the 83rd or 83rd fundamental particles in the universe, protons, neutrons, and electrons. And so keep adding zeros to the number so you get to 120. And that's how organized the early universe had to be, so that it didn't just turn around and wrap back around itself or give you nothing when it tried to expand and recollapse. So that level of organization, it's imagine that you took all of every atom on Earth that we have and you tore it apart and you threw it all together at one time in one direction, and it landed in the exact shape of this world, this Earth. Every one of them hit precisely where it's supposed to be and landed here. That doesn't even begin to tell you how complicated the 10 to the 120th would be in terms of entropy organization. Like, it's just nuts. It's stupid. There's only one word for it: stupid.
But so the point here, though, is that you can't just reset. You end up with entropy that continues from one of these oscillating universes to the next. And so the question then has to be, well, how did we get where we are if there's been an infinite before us?
Yeah, so this is what Sean Carroll tried to argue at one time, is that when he was talking to Bill Craig, is he said, well, maybe there was a universe and it's kind of going this way, and the arrow of entropy was reversed. So everything's going backwards entropically, and then it hits, this Big Bang point, and then it comes out and is ordered this way. And Bill Craig was like, if the arrow of entropy is reversed, that just means that it's in reality going this way. So this isn't one universe, that's two universes, or two non-causally connected domains coming from the now non-causally connected domains coming from this universe. So that's not one universe, that's two. And Carroll stopped talking about it after that point.
Seemed like a very sophomoric argument.
Yeah, it wasn't well thought out.
From a very smart guy.
So that's the problem. Like, nobody thinks Sean Carroll's not smart, but he also hasn't built a successful theory yet. Yeah. And part of the reason, I'm not going to accuse him because I'm sure he's 10 times smarter than I am, but ultimately, if you keep trying to do it, your work isn't working out, you go do something else, and he turned out to be a gifted speaker and popularizer. But at the end of the day, is his work in physics important? I mean, it's important, and hey, we tried that and it didn't work, so that's good. But he doesn't have a positive result yet. He's got a history of negative results, which is fine. Again, we claim that that's what we want out of science, so that's good work. But he doesn't have, bottom line is he hasn't produced any working theory.
So I don't know Sean Carroll at all, other than what he's said. But it is an interesting indication that just because you are super smart doesn't mean that you don't have different alternate, what's the term, reasons for doing things. To your point, where was it? You know what I mean?
Yeah.
Smartest person in the world can be blind by their own emotions.
Well, this is why.
Sorry, I sent you down a rabbit hole.
No, to that point, there was nobody's a better example of this than Stephen Hawking. Like, anybody thinks Stephen Hawking wasn't smart? Yeah. So obviously, but he was.
I'm not enjoying PowerPoint right now.
You really want to ask this right now?
I don't know why this isn't working. Okay. I guess we'll figure that out. You guys maybe remember this slide where he basically has this, and he just rounded off the Big Bang and was like, see, it's round. And so since there's nothing south of the South Pole or north of the North Pole, there's no time before the round thing. But he also claims that from the round thing up to this little line that you can't really see right here, that's not happening in time. That's another spatial dimension. And the problem with this, and all respect due to Stephen Hawking, is that's incredibly stupid. And what I mean by that is not he's stupid. What I mean by that is the idea is so obviously wrong that the only way to believe that is to will your way out of seeing what's obvious, which is this thing right here ordered before this thing? Does this causally, is this point right here causally prior to this one right here? If the answer is yes, then it's temporally prior to this right here. That's what we mean by time. So the only way to do this is to completely ignore. And by the way, what they didn't tell you when they popularized all this is that this line right here is a cut. And they've glued together this section of it is done under different rules of math than this section is of it. They don't use the same rules. So they literally cut and spliced two sets of rules together and were like, see, it works. If you did this on a test in school, you'd get the problem wrong. But if you got a PhD, they'll publish the paper. That's a problem. Okay.
Yeah.
As happy as you're going to be on this show.
You know, I've had parties where it's like, well, the universe could be infinite. I'm like, well, actual infinite's absurd because
Let's go back. You said I had parties?
Yeah.
I've been to parties. Yeah.
Okay. You went to parties, and this was the reason for the party. Ladies and gentlemen, welcome to the...
I've had conversations.
Oh, okay.
Had events.
I was going to tell you that I was offended by not being invited to these parties. But yes, so, okay, so you've had parties where...
They say, well, how do I know, like, the universe isn't infinite? And I'm like, well, actual infinite's absurd because, like, the book loan example.
Well, hold on. That question has an answer. How do I know the universe is not infinite? All right, that one you can answer.
Time and space are both.
Yeah,
Well,
yeah.
I bring up, if infinity contains contradiction,
Yep,
the universe would not be infinite.
right.
But I don't have a short
Pithy
way
answer to that, yeah.
make that clear.
So first, of course, what you have to do is get them to say what they mean by universe. So do you mean, and let's say that you say something like this. By universe, do you mean causally connected domains?
I say sure.
Okay, so now how do we know one causally connected domain is not infinite? And the easiest one to say is use Gord, Guth, and Lincoln to say, well, we know what our universe looks like. There's an H0 expansion factor, the Hubble expansion. And if the Hubble expansion is greater than 0, then it means that on average over time it's been increasing. If on average over time it's been increasing, then that means that at a finite time in the past, it was down at a single point. And that means that the universe is finite in the past. Now, how are you going to say, well, what about if it's infinite in the future? You say, okay, well, there's no time where it's not finite. So why, what do you mean by infinite? They'll be like infinite, like not ending,
Well,
right?
it-
You'll be like
that's
not
That's based on our
finite.
observations in our light cone, whatever.
No, that's philosophically speaking too. So,
That's the part they reject.
but why? You can't just say, I reject that. You have to reject it for a reason.
The contradiction doesn't jump out at them. Or they go like, well, like, our human brains can't comprehend it.
So where I would go with this that will absolutely stymie, if you're looking to win an argument with somebody about infinity, this is what you do. You say, I'm talking about numbers. How old is something? How big is something? Okay, those are the things that we're talking about here. These require you to say numbers. How old is something? This is 4 billion years old. How big is something? This is, 98 billion light years across. Okay, so those are numbers. You're telling me it's infinite. That's not a number, that's a process. So talk to me in numbers. Right? You said, you're asking me how old something is, you want a number. And then you say, is it possible that it's a process? Which do you want? Do you want a process or do you want a number? Which
How do you
one?
mean it's a process?
Because it means not finite.
Yeah.
That means not ending. If it's not ending, it's continuing. If it's continuing, it's a process.
They'll pull up some math YouTuber that doesn't treat infinite like a process.
Who's that? Nobody treats it like a process. So this is the sleight of hand that they do. This is the sleight of hand that happens on this one.
Well, math PhD people.
math PhD people will do that. This is what they do. They'll say, when you talk about infinities, you talk about cardinalities. And you say, what's the cardinality? This is the word they use, cardinalities. Cardinalities, they'll say, is the size of the set. And they'll talk about infinities of different cardinalities. The reals are of greater cardinality than the natural numbers. That is to say, the size of the set of the reals, that's all, point whatever, let's say the reals, that's greater than the cardinality of the natural numbers. They'll say the cardinalities of the natural numbers and the evens are the same. What I mean by that is 1, 2, 3, 4, 5, 6, 7, 8. They're the same. They have the same cardinality, supposedly the same size of the set as 2, 4, 6, 8, 10, 12. And you say to the mathematician, how are you possibly saying that? They'll say, because you can create a bijection, a one-to-one relationship between the first set and the second set. And what they'll do is this. They'll say, here's 1, 2, 3, 4, 5. And here's 2, well, we'll do it this way, 2, 4, 6. So what you can do is I can use a y equals 2x and say, okay, well, I can do 1 times 2 gives me 2, 2 times 2 gives me 4, 3 times 2 gives me 6. And so I can create a one-to-one relationship with all of these. So therefore, they're the same cardinality. The size of the set's the same. Now, never mind that what they've actually done is this.
So you're just playing with rules of using infinites.
Well, watch what they did here. They skipped these numbers. So where did this number go? Where did this number go? Where did this number go? They got left out. Okay, so 2 doesn't have any meaning if its predecessor isn't 1 and its successor isn't 3. All right, so you can create a bijection there. That's true. But the problem is the mathematician says if you can create a bijection, then they are the same size. But watch this.
It's math of infinities.
Yes, sir. Thank you for the help. Watch what you're doing here. I can create a bijection by saying this one and this one are paired, this one and this one are paired, this one and this one are paired. Okay, but I can also create another bijection on these same sets by saying these are paired, and these are paired. Now, what does that mean? What have I just created, logically speaking? It both has a one-to-one relationship with half of the set, and it has a one-to-one relationship with the full set. That's a contradiction. And mathematicians just don't talk about this. They throw it out completely. That's ridiculous.
They say one infinite set is bigger than
Yeah, that's what I'm telling you. The cardinality is, they use the term cardinality because you say, well, the number of elements in the set. They're like, no, it's not the number, it's the cardinality. You'd be like, what's the cardinality? It's the size of the set. Like, size is a number. Right? It's not, if you're not talking, I mean, you can compare them, but if you're going to say this cardinality is greater than that cardinality, by that I mean you can't create a bijection between them. I'll say, well, you can't create a bijection between these unless you do them at different rates. That's the point. So the evens are not sitting out there on their own. The evens are the selected subset of the natural numbers. So you have to skip these in order to get the evens. And so my counter argument to this is, all right, if you want to do a bijection, I'm just going to create a bijection with the ordinals. Okay, so here's 1, 2, 3, 4, 5. Here's 2, 4, 6, 8, 10. No problem. This is first. That's the first element. That's the second element. That's the third element. That's the fourth element. And the other infinities out there, the larger infinities, the larger cardinalities, you can construct them, many of them. And so what you can do is just say, well, I'm going to construct them using some method, and the first step of the method becomes the first number, and the second step becomes the second number. Now, they won't be ordered on the line unless you do another process on them, but I'm going to say, tell me why order has to be important. You admit that I can construct them, so I'm going to create a bijection to the ordinals, and the ordinals are the smaller cardinality. So, and the ordinals have a bijection to the naturals, which means they're all the same size. Now, why are they all the same size? They're all the same size because they're a process. They're a process, and you can make them happen at the same rate if you want. So the point is, this is a number is an end of a process. Okay, so if I can be more specific, when you get the number 5, where did you get that? Where's the number 5 come from? In modern number theory, it's the successor of 4, which is the successor of 3, which is the successor of 2, which is the successor of 1. And they generate this by starting with the null set, that's the empty set, and then the set that contains the empty set, and then the set that contains the set that contains the empty set. This is how counting is done in modern set theories, or Mello-Franco set theory with the axiom of choice is kind of the popular one today. Sometimes this gets written as this, the null set, and then the set that contains the null set. Of course, there's a problem here. If a set is a collection of objects or elements, and there are no objects or elements, it's not a set. So they're literally trying to make a set out of something that doesn't exist. You can't count nothing. It doesn't matter how many times you count nothing. You don't have anything at the end of it, other than you're counting. And that's the point, is that the number 5 isn't a thing. It's us counting, which means it's a process. And what we're saying is, I'm going to do a process 5 times. When I've done that process 5 times, I'm going to say that's what I mean by the number 5. So by that definition, there can't possibly be an infinity. Ever. Ever, ever, ever. You'll always have a finite number, unless, even if your process doesn't end, if at any time you're like, what's the number right now? Your answer is, oh, I'm at step gajillion. You don't ever end. If the process doesn't end, you've not gone, you're still in the process. And so it's not ending. It hasn't ended yet, but it doesn't mean it's not ending. It might end someday, in which case, okay, now you've got a number that you can say, well, that process went for X steps. And that's the problem, is modern mathematics doesn't do any number theory education for us, so we don't realize that this right here is the end of a process. A number is an end of a process. So you can never have an ongoing process result in a number as the end of, at least that's part of the process.
I guess after that, they just say, well, experts disagree. And
Yes, but they're logically self-contradictory. So which expert do you want to listen to?
The experts say they're not, so and they know better than me.
But then you turn around and say, can you recognize the difference between this is a cup and this is not a cup? If the answer is no, then you're right. There's nothing we can do about that. But if the answer is yes, then, hey, here you go. Tell me how set theory works. Because that's the way they say it works. Like, I'm not making that up, guys. That's literally what they say.
And that's what I meant by rules of infinities, that you have to, if you're going to talk about infinities in a, quote, meaningful way, you have to avoid these contradictions, and so you just don't do certain things.
Yeah.
Right?
No.
Same thing with...
So say that again.
imaginary
Say that again. Say that again.
So you just don't do certain things.
So that's very important. When you've got one set of rules, I got one set of rules for numbers. But once they become transfinite numbers,
Yeah.
I'm not allowed to do, and they'll fill in the blank with a whole bunch of rules they can't follow. You can't subtract non-finite, that's the finite numbers,
Right.
transfinite numbers.
You end up
Why
with
not?
contradictions.
You tell me I can't take some away from there, like not that violates the rules. You're like, then we're not doing anything other than playing games at this
It's the
point.
same thing with imaginary numbers.
Yeah, right.
And we apply physical, like phase or whatever you want, to imaginary numbers. But the reality is imaginary numbers you have to play by the rules.
So I hate imaginary numbers because of the way they've come to be and what people believe that they represent.
Right.
I love them because it's actually the first step. Remember how I was talking about, like, here's all the air in the room, but it was more dense here? Imaginary numbers are a way for you to calculate what happens when you pass through this density delta. They are a way for us to talk about, if you're using a circle process, a process that's circular or has a frequency to it, so oscillating waves, et cetera, once you put them in the particular temporal domain.
Apply meaning to it.
Yeah, if you've got a sine wave, by the way, and you say, instead of running it through time, I'm going to run it on a circular clock, I'm going to run it on a clock that repeats itself, that wave like this turns into a circle. That's the whole reason we do it. That's why the square root of -1 is used as the factor, the complex portion of the number. It's because it turns a sine wave or a cosine wave into a circle. That's great. It helps us calculate. It's something wrong with the way that we do this. It doesn't map one-to-one with reality, but it's a good idea, and that helps us. The problem is people haven't realized that this timeline is not the same as this. Time isn't repeating itself, guys. Like, you have to plot it linearly, causally. Okay. I severely apologize to anybody who wandered in the room and didn't think they were getting a number theory lecture. This is not completely normal for us here. But to your point, for the multiverse stuff, like the simple answer is this. Hey, I see that you think of a multiverse because of the Marvel universe. Tell me why you think that's different universes than it's just one big connected universe. And they'll say, oh, well, they're separate because you have to move from one to the other. Well, I move from one to the other in this universe. Well, okay, but they're not always connected. Well, I'm not always connected to the internet. That doesn't mean that I can't order that I'm not, that's not the same internet and I'm not the same guy. So the point that you're going to get to eventually is, if they're connected, they're the same universe. And they're like, okay, well, they're not connected. And you say, well, then why do you think they're there in the first place? And the answer is, I don't know, people just talk about it. And you say, do you know where the multiverse came from? And they say, science fiction. Be like, no, it was literally philosophers trying to multiply their probabilistic resources to explain the exquisite fine-tuning of this universe. And if anything, leave it at that. And say, like, nobody thought about it there being a multiverse. The idea of a multiverse didn't emerge until we realized that this universe was so improbable that we have to be drawn. We just drew a royal straight flush 1,000 times in a row. Somebody's cheating. Or we're drawing from an infinite number of cards and we just happen to be on the super lucky deck. Right? That's it. That's literally why it's there. There's no other reason for it. Because there's no metaphysical reason for it. It's only there as a MacGuffin. Okay. Other questions? That's all I got for Seth. Yeah, yes, sir.
We finally finished before the timer.
I know. I don't know what to do with ourselves. We got 7 minutes left, so I'll open it up to anything anybody else wants to say. I've heard what we're saying here. Eric, you've seen a semi-product that we've got here. Nobody has written me back on stuff on stuff that they really want in terms of these things. In addition to what you already generated this, so I haven't heard anything additional to that. But the deck is always open. So if you get any ideas or anything else you want to send, please do. And maybe be thinking a little bit too of, we've heard from our experts and you all that in terms of content, that it's nowadays, at least as far as it seems, as far as we can tell, it's not enough to have good content out there. If you want your content to reach more people, you have to be generating content at a particular rate with a particular amount of interest level that it would generate. So I think it's easy for us to mastermind our way to, okay, these are the things up here that we want to put out there. But the question is, what do we put out on a weekly or bi-weekly basis? So if anybody's got any bright ideas on that front, by all means. In short, we have not generated the ideas, these deep ideas, at a rate of one a week. You know what I'm saying? Hey, well, here's a solution to the Trinity. All right, what are we doing next week? Here's why infinities are self-contradictory. All right, what are we doing next week? We can probably pull that off for a year of stuff that we've already gotten under our hand. But
it would be interesting, and this is, you can link it to theology, but the difference between causality and probability, meaning that when we get to the quantum universe, we think in terms of, well, it's all probability. But the reality is probability is just a way of talking about things that we can't observe well enough to determine a cause.
yeah.
right? And yet the idea of probability has grown into this sense of that it can be two things at the same time. You see what I mean?
Yeah, in fact, that's the Copenhagen interpretation of
Right.
quantum mechanics. So yeah,
People say that chance causes something.
right. Yeah, and chance is not a force, right? There has to be some. It's a recognition of a process that kicks out more than one solution out of a domain of possibilities. So chance,
Which I don't know if it actually exists.
right?
And it is linked to theology in that is used for exactly what Seth was talking about.
Well, yeah. So I think to both your points. Tell me if I'm wrong on this one. The Christian that believes in this universe, there's no such thing as chance.
Correct.
Right? It just doesn't exist. If by chance you mean, so I love your question because this is recognized. So the guy that is kind of some of his reasoning, it's not his alone. He's articulating other people's reasoning. Grant Sanderson's reasoning has to do with this, where he says probability. He talks about the frequentist interpretation of probability versus kind of competing theories of it. They're really two big ones, but that he's saying probability is an expression of us not knowing something.
Right.
So if you're flipping a coin and you knew all of the vectors and momentum and all that, it's not a chance it's going to end up on heads. Like it's going to end up on heads, or maybe you know it well enough to say there's a 90% chance it's going to end up on heads, given the way that you flick this thing and the coin that you have and the surface it's going to land on, and the gravitational field you're in, and the air and all that stuff. So it's simply an expression of ignorance. Same way, if I deal you at the blackjack table and you see a king and you see a 8 and a face down card, it's already, the card face down exists. You're like, well, there's an X chance that I'm going to win. Like, no, you're already going to lose, or you're already going to win. You just don't know which one it is. And so the question is, how much of your money are you willing to bet against somebody else, by the way, that also has to not know, right? You running at the blackjack table against a dealer who knows all the cards that went out, you literally lose every time. Maybe there's a couple of times where you'll tie, but you lose basically every time because it's not a game anymore. Because it's not your ignorance versus ignorance, it's certainty versus uncertainty. And the certain guy's going to win every time unless he's trying to lose. So the fact that we don't know should never have been parlayed into, well, we don't know, and therefore it's unknowable. That was positivism. That was verificationism, and that philosophy is dead. And we have not pulled our society out of the stupidity of speculation from the early 20th century.
So I think
this is what Schrodinger was trying to get at.
it's also quantum mechanics and Heisenberg uncertainty principle in that it's if you observe it at that level, you alter it.
Yeah, but that
doesn't mean it's uncausal. It just means that you can.
So, but that's not true. So they tell us that, but I'm gonna quibble with the language.
All right. Yeah.
So Heisenberg says, here's this particle moving, and if you're going to measure the particle, you have to interact with it. Because the way that we measure the momentum of an electron or something is that we go bounce something off of it and see what happens. So he says the more finely you're going to measure something, the more that you're going to affect it, which means the less certain you can be about its either location or its momentum. Like, so those are a trade-off. So what they said was, we can't even imagine how you would measure how you would do that without interacting with it in a way that changes one of the two. So therefore, it is a facet of reality. It is meaningless to say that thing actually has a position and a momentum.
Yeah, so that's what I'm talking about.
And that's the problem. That's completely false, but we bought that as a
you end up
culture.
with electron probability clouds, which is the best that we can do. That doesn't mean that the electron is truly
Smeared out over all that distance. It just means that we don't know. That's right.
And I think that same concept is then applied to theology.
Yeah, but what it means is also, like, if anybody ever comes up with a method by which you can measure those things, all that stuff goes away.
Yeah.
Right?
Or
It's completely wrong.
that feeds into the idea that things can be more than one thing at the same time, right? More than one place.
Right. And to the point then on cardinalities, etc., we have given up on logic. So if you're wondering why all these crazy things are out there, I'm not kidding you. The worst thing that happened to men's minds in the 20th century, in the early 20th century, was not World War I. The worst thing that happened was what we decided to do in math and physics. The mathematicians embraced Georg Cantor's infinities, and it's killed us since then. And the physicists embraced quantum mechanics, and it's killed us since then. And the reason that the reason Leonard Susskind, brilliant physicist, wasted, I'm going to say it completely out loud, completely wasted his life. In 50 years, nobody's going to read Susskind. Nobody's going to care. He wasted it because he went after string theory. Because the bad math and geometry and the bad physics come together perfectly in string theory, which is why it's complete garbage. And it's a waste of time. And we took that brilliant man's mind and we squandered it because we bought off on these two logically corrupt systems. We have to go back to these systems and reestablish them. And that works, but that means philosophy, it means theology. By the way, if you want to know why we're in the same, why are there 1,000 Protestant denominations? Before those guys gave up on math and physics, the Christians gave up on logic, and now we're stuck with a bunch of self-contradictory statements in our own doctrines and theology because we didn't bother to sit down and work them out. That's what it is. Because people wanted what they believed to be true more than they wanted it to be rational. And that's a problem. So we all got to do it. As philosophers, we have to do it. As theologians, we have to do it. As physicists, we have to do it. As mathematicians, we have to do it.
Do you have a list of those contradictory?
Yeah. It's getting bigger every day, but yeah. All right. Yeah, we can. Oh, yes. Well, a lot of this is meant to address that. Some of it. The most important. What I think are the most important parts. If you haven't adored this adorable baby, please feel free to do so before you leave. But thank you all very much. God be with you this week. Thank you for your help. And everybody's invited in on the video stuff as much as you want to be participatory.